Welcome to day 613 technical session of 6-day online faculty development program of electric vehicle and charging station for sustainable development sponsored by AICTE ATAL. And our resource person for this session is Professor Pradip Kumar Sadhu sir. On behalf of organizing team, I welcome you sir in our today's technical session. Before you start your expert lecture, I would like to share a short biography to you to the participants. Pradip Kumar Sadhu sir received his bachelor and postgraduate and PhD degree from Department of Electrical Engineering, Jadavpur University, Kolkata, West Bengal, in India. Currently, he is working as a professor and ex-head of Electrical Engineering Department of Indian Institute of Technology, ISM Dhanbad. He served BIT Mesra, Ranchi as a faculty member of Electrical and Electronics Engineering Department. Prior to join BIT Mesra, he has served different institute for 12 years. He has total experience of 37 years, of which 25 years in teaching and 12 years in industries. He has 30 granted patents. In addition to 2 more patents in his name are under process. He has several journals and conferences publication in national and international, including IEEE Transaction, Industrial Electronics, IEEE Transaction Systems, IEEE Transaction on Instrumentation and Measurement, IEEE Transaction on Sensor Journals, IEEE Assess, Solar, Renewable, Building Environment, Sustainable Energy Reviewers, IIT, General Transmission Distribution, IIT Science, Measurement and Technology, IIT Smart. He is principal investigator of few government funded projects also. And sir has developed a pacemaker battery recharger for enhance the service life that allow recharging the battery of pacemaker technology, for which patent has been granted now. And also sir has last but not the least, he was selected as world's top 2 scientists for the year 2024 by the SVS and the Stanford University. With this, I request our expert, Professor Sadhu, Pradip Kumar Sadhu sir, to kindly enlighten us with his word of wisdom. Sir, please, you can continue.
Okay, thank you for long introduction. I'm not so level of that, but we'll try for this best. That today, basically your FDP program on the EVs, and now we have to discuss EV charging system. Basically, EV charging system, other system that basically we are doing the research work over the contactless charging system or wireless power transfer system. So over the surface, some vehicles are there. You are habituated with that e-vehicle and how it will be charged up. In previous session, I have taken this class in your FDP program. But today we'll discuss some special application over this contactless charging, and as well as who will supply the huge power over the e-vehicle whenever it will adopt the e-vehicle. Nowadays, over the road, if you calculate that only 5% or 4% vehicles are e-vehicle, and whenever the 100%, maybe 95%, 99% e-vehicle will come, so the turmoil on the grid for the charging, it will occur. Do you agree? First point, this point. Please respond.
Yes, sir.
So actually, due to the connection or network issue, in between that, I am asking this, that am I audible or not? So in this case, in previous session, we have discussed this, how the EV will be charged up at the time of dynamic condition. That means whenever it is running, then also it will take the charge, and that is the benefit of the EVs, that fast charging, whatever the other charging system, it will not help to reduce the tear weight. Tear weight means that is that means empty vehicle weight, it will not be reduced. That means in normal technology, fast charging technology, different technologies are there for charging, but only charging system, when it is available over the running condition, that means at the vehicle is at running condition, at that same time the battery will be charged up, or vehicle requirement power will be taken from the your over the contactless power transmission system. Just like in your electric train, or it is not contactless, it is taking the contact within the traction power. It will take the power from the overhead wire, and it is a contact power transfer. So in place of this contact power transfer, whenever that part is there, the idea is basically power will be taken from the grid, but at the same time, there is no requirement of as such battery for the running of this vehicle. So these are if you visit the Kathmandu, there the electric trolley buses are there. It is over like tram, that two pantographs are there, trolley pantograph, that will take the power from the rooftop wire. So where it is that is the power transfer is basically the not contactless power transfer. It will be here, we will discuss about this contactless power transfer, but it is for the efficient contactless power transmission system for underground mines. Same thing is applicable for efficient contactless power transmission. Here it is for underground mining operation. In other places for your submarine operation. The submarine also, that batteries are there under the sea. So there you have a requirement of charging of this battery. So sometimes the battery is discharged under this condition, you have to charge up the submarine battery. So under this condition of submerged condition, it will be charged up. This technology is required. There is no contact charging. Basically, it is a contactless charging. So contactless power transmission. So next, for this huge power requirement, whatever we have discussed for EV, when the 99% vehicles are EV, so over the grid, you have the super, like your super capacitor bank, super battery bank will be connected over the grid. So how can you manage the power? That's why we have a requirement of we'll come here for short time, as because if I selected this topic, basically the EVs, your FDP topic is the EVs, but here it is also vehicle for underground mining operation, we'll discuss later. But huge power from where we collect, actually that I shall give you the information that for this EVs charging system, if I take the power from the grid, basically it will come from the 80%, somewhere 60% power is taken in the grid from the thermal power station. And again, how to reduce the carbon footprint. Basically, whenever you take the EVs operation for this charging system, you are taking the electrical power from the grid, but this electrical power will be generated by the maximum 80%, 70 to 80% power is generated from thermal power station. And this thermal power station will emit the carbon dioxide, carbon monoxide. So this carbon footprint, how can you manage, or how can you drop? Directly EVs will not create the carbon monoxide, or it will not generate the carbon dioxide, as because there is no burning of fossil fuel. So, but as such, EVs also have some problem, that is the carbon footprint. How can you reduce? As because if you take the charging power from the grid, do you agree? This part. So, shall I enter to the exact domain?
Yes, sir.
So here this, we just change over, then again come back to this slide. It is a amalgamation of these two. We'll see that, is it visible? That
Sir, it is visible.
full screen mode, it is visible, huh?
Yes, sir.
Floating PV power generation, how it is correlated with this EV, that you have a requirement of huge power for this 99% EV. Whenever it will load will come across the your grid, or from the grid, EV will take the power for charging. So you have a requirement of huge power, and if huge power will come from the thermal power station, so then again the carbon footprint will be there, and it cannot be possible to reduce the carbon footprint, or in the atmospheric condition you cannot reduce the carbon monoxide, carbon dioxide. That thing cannot be possible. So we'll see this matter for the floating PV power generation, a focus on inland and offshore, how it is correlated with the EV. So if I say, who have the experience that from Kolkata to Chennai or Kanyakumari, the maximum places that national highways are passing nearby the Chilka Lake, this type of inland waters are there. There, if we generate the floating PV power generation, it is not like that the your rooftop or building integrated photovoltaic, it is not that. So it is floating PV power generation. So anyone can say that what is the benefit of floating PV power generation over the rooftop or land-based PV power generation or BIPV power generation? Can you indicate some focus point? Anyone who are present in this session? Maybe answer may be wrong, or I can correct you. Anyone?
Land-based solar panels utilize the useful land, green lands, and in case of floating PV panels, it doesn't utilize the useful land. It utilizes the water that is not used for any agriculture purpose and other purposes.
Is a very good answer you have given this over the session, that you have noted this agriculture, you have focused over the reduction of agricultural land, or that it is correct. But the thing is, on the point of view of floating PV compared to rooftop, compared to building integrated, compared to land-based PV system, what is the benefit of that? You have to note as an electrical engineer, what is the applied physics here? That PV is nothing but it is a PN junction, semiconductor junction. So there, whenever over the PV, over the rooftop, the PN junction will be much more heated. That means for reflected wave of irradiance, then global irradiance, that global radiations are there. So albedo radiations are there. So different types of radiation. It will create the much more heat over the junction. And whenever the basic of this study is basically whenever floating PV, then advantage of that, the leakage of PV junction, that means PN junction, leakage current of PN junction is very less. That means the natural water will just cool down the PN junction. It is looking like a radiator, natural radiator of like your the IC engine, or that radiator is used for extraction of heat from the engine. So here the floating PV power generation is basically, it is very much helpful for e-vehicle power supply. Over the road, nearby the roadways, that whatever the big lakes are there, so there you can generate over this PV power generation almost 1.1 times, 10 to 20% much more power will be generated compared to the rooftop, or compared to land-based PV system or BIPV system it will generate. So this efficiency of the generation, power generation, will be much more. Do you understand this point? Anyone? Please respond. Anyone? Please respond that whenever it is floating, then it is a natural radiator. Anyone please respond?
Yes, sir.
Yes, sir.
So actually, I'm just assuming that network problem is coming or not. Please respond. If the answer is wrong, I shall correct it. That will be better for interaction. So this from the first slide, floating PV power generation is the better option for huge requirement of EV power charging. So go to this next, that here it is the understanding of floating solar PV, need for floating PV, components of PV system, PV floating plants outlined, current challenges, advantages, places of installation, floating power, economic analysis, solar PV installed countries, references. So understanding of solar PV, what is floating solar PV? It is looking like that. Here you see that it is a technique of installing PV on water bodies instead of conventional place like land or rooftop. What I am telling, here you see, this is the water bodies. You follow this, the hands movement, the total area of the water bodies over the water bodies. This is the your, that is floating PV power generation plant. And these water bodies will help you. The cooling system of these PV junctions, all the panels will be less than 2 to 4 degrees Celsius than the compared to rooftop or land. Sometimes we have seen the 6 to 8 degree centigrade temperature difference, as because in summer, whenever the land atmospheric temperature is near about more than 40 degree, so water temperature is 30 to 35 degree. Am I correct? Please.
Yes, sir.
Yes. So next one, what is the technical thing? Just I shown this. It is a Mumbai city elevation view, and here in the Chennai to Kolkata or Kolkata to Chennai highway is passing through the Chilka lake or different lakes. So there we can install the floating PV power generation as well as the land-based PV power generation. So it will help the huge power requirement of the EV, and there this whole water bodies, actually it will not be covered up. Someone will give the question that if the total water bodies or of the over the lake here, this, if it will be EV will be covered, then the biological problem will start. Is it not? That over the bodies, there is a rules and regulation for water bodies, water regulatory authorities of India, that here you can cover a maximum area of catchment area of hydel power station, these views, or catchment, that means cooling water requirements in case of thermal power station. There, if we install this type of PV, that the floating solar PV, so there the 10 to 12% only can cover up that total area. Out of this total area, only 10 to 12% will be covered up with the floating solar. So here it is the overview of Mumbai city. We can put this, that what is the basic components of the PV system. Actually, the pontoon, floats, mooring system, solar PV module, cables and connectors, floating structures. So basically the pontoon and floats is basically this type of floating blocks are available, floating desks, and that will be clubbed together in the matrix formation. It is a 2x2 matrix, and there for requirement of much more, it can be floater can be used, and in pontoon is flotation device with buoyancy enough to float by itself as well as with a heavy load. So mooring system. A mooring system is a permanent structure which that is the, here you see that floating solar PV, that is the power station generation, and this is the mooring system. It will just protect that it will not float from one place to another place due to the wind flow or that. So it will be just tied up, which is similar to anchoring system of the boat. Do you agree? Please respond.
Yes, sir.
So it is nothing but, here it is not calling the anchoring system. Anchoring system is called in the sailing boat or ship or other maybe steamer, but here it is called mooring system. So mooring system will help you. This system will be stagnant over the water bodies in one place. So these are the solar PV modules. We cannot waste our time. Better the applications of the contactless power transfer in the other vehicles. Here you will see this is the cables and connectors. This is very, very important. Electricity is drawn from solar array and transported to the land. Actually, in the solar, floating solar, the over the water bodies, these are connected. Actually, whenever you transmit the power to the land, I just show you the schematic. Here, this is the schematic figure. That means solar panels are floating solars are there. These are the floater. And after this structure, you have a need of the electrical power supply cable for supplying this cable with the grid. These are the substation where you will change this from DC power to AC power. But the thing is, if it is the structure, so cable is inherent part of this power supply system. Without this cable, you cannot do anything. If it is a Chilka lake, so this Chilka lake, from this you can collect this power, and from this you will inject this power to the grid. In case of the offshore, suppose it is Arabian Sea or that thing, there the saline water, or in Chilka also semi-saline water, over this under the cable, you can send this power over this PV floating plants outline. So there is some dangerous issues are there with the cable. We will discuss. Here we see that these are the connection. The power can be fed to the grid or stored in batteries. High temperature resistance, waterproof, robust cables are to be used to provide a long service. So this is a grid connected inverter. That's because we know that all the solar power is basically the current source power. Inside these I to V converters are there, and then voltage that integrated, line integrated inverters are there. So it will transmit the power to the grid. So this is a floating structure. This floating tracker, cooling, this type of things are there. Submerged photovoltaic solar panel. So these are the units are there. These are the mirrors for getting the more irradiance over the solar panel. And the power density, generation of power density will be much more. Next, this is the experimental structure, floating structure. We have tested in IIT Dhanbad. Location is fountain bed for hardware simulation in small water body. Basically, small water body and large water body, some differences are there. So here we have tested this over the fountain bed in the Executive Development Center. This fountain bed is dried up first. And what is the generation? What is the losses? And next, this fountain bed is filled up with the water. This normal water, not saline water. So here that it has been taken the result for this. What is the your efficiency of the system? It is basically 100 watt solar panel is used for this testing purpose. And here it is solar emulator. Here the solar PV graphs are coming directly. And these are the voltage of the panel after the I to V converter. Here it is the load current showing this. And basically we have used this resistive load or the your unity power load, unity power factor load we have used. And next, the floating structure experimental setup for 300 watt FSPV system in IIT Dhanbad swimming pool. Here over the swimming pool, we have used this floater. That means very simple, small price applications. That is the bike or scooty, that tube, air tube. We have collected, we have purchased this thing as because the HDPE platform. Later I shall show you that what is the problem with this, that floater. These are the commercial floaters are available, but this imported floater will not be sold out for 1 piece or 2 piece or 10 piece. It has to be purchased for 100, minimum of 100 HDPE platform. This purchase, but this for experimental purpose, we have used this type of thing, flat. This here it is not possible, the slanting. That means tilt angle is not possible. Only it can be, we have tested for highest result that from 9 AM to that 4 PM we have tested this thing, as because near about 12:20 we will get this the maximum result over this. So these are the from the emulator we have taken this result, that maximum time, clock time and noon time, where we will get this maximum power generation. And here for your information, we have tested that at the condition of rainy season, what is the that rains, whenever rain over is fallen over the panel, so immediately efficiency will rise. Why? Now that junction of the temperature junction, that temperature of the junction will be reduced. That's why that power will be enhanced from the system. And this artificial rain arrangement we have done here. And then what is the acidic rain, this type of testing we have done this thing. And after that, what is the thing in case of the dust deposition, that over a long period, the dust deposition, after that, what is the reduction of power over the solar panel? In case of the dust deposition, land-based solar PV system, there the dust deposition we have counted much more than the floating solar. And these water bodies, is the absorber there, and as well as at the time of rainy season, much more clearance will get from this, that transparent over the glass. Glass is basically protect the hardened glass is there over the every panel. But after the rainy season, after the rain, whenever rain is over, so glass will be cleared up and this efficiency, power generation efficiency will be much more. Next is, these are the concept of hexagonal design, how in the small covered up area you will get this maximum power generation. This flexible floating hexagonal PV design. So these are the floating solar component. Basically over this platform, the solar PV panels, if you follow this, the hand that it will be fixed up over this tilt angle. And this tilt angle, basically the tilt angles are different. That means if this system is over the dull lake, or if it is system is installed in Kanyakumari, tilt angle is not same. Do you have any idea? Anyone? Please respond. Hello.
Yes, sir.
Yes, sir.
So in the Kanyakumari, it is near the equator, so that it is angle, tilt angle is less. That means much more flattened, 11 degree. Whereas Calcutta, that Bombay, this area is 23 to 24 degree inclination. Whereas in Srinagar, that is the 33 degree inclination over there. In Leh Ladakh, Pangong Lake. So this type of inclination depends on geographical position of the place, and that is over the longitude and latitude. These things are available. What is the tilt angle? So after that, if it is a dull lake or if it is a Chilka lake, the common structure that here we have to take this, the power transmission for the cable is required. But whenever underground, under your water, so cable has some more monitoring system is required, as because if it is there any leakage or something else, so cable may be damaged. That water injection or maybe the saline water injection will damage the cable over long time. So life of the cable will be shortened, and other things will be discussed here. The current challenges due to increasing application of non-linear load, power quality of the supply is severely severely disturbed, and these harmonics result in increasing the cable resistance. This one we have known that from the harmonic analysis, that what fundamental with the fundamental component, what are the order of harmonics are present. If the order of harmonics are much more third order, fifth order, so what happens? For the more frequency, the cable is almost short-circuited, as because XC is 2 pi FC. More higher order harmonics will create that means it is the leakage path of the current, and that cable heating will be much more due to that reason. And always the harmonics are there due to the high frequency or maybe the power frequency inverters are there. So that inverter will generate more or less harmonics. It may be the total order that TSD will be 5% within this PSD TSD. If it is 5%, then it will be allowed, or other than this will affect the bad effect over this cable. So this thing, you will see that due to this cable power transmission, this 100% is the fundamental, the third order is 50%, 35%. This higher order harmonics will create the heat over the cable, and that will create the shorten of the life of the cable. So these are the, if you have interest, you will get this. We will conclude this experimental procedure. That means condition monitoring is required. That how much cable will be heated up with the thermocouple. They are the three transducers. So they are sensors. One A, which is over the lab. B, over this loop of this cable. It has been fixed up two sensors, B and C. What is the temperature difference over there? Depends on that. That is the loss. Heat is specifically, it is proportional to loss. So these are the experimental system. These are the cable. That 100 ampere cable is passing through this, and we have injected this in the intentionally different harmonics, and over this, what is the heat generation is there, and due to that, we have taken this result over the slide. Whenever you get this grip ammeter is 100 ampere. We have tested it. These are the results. That grip ammeter rating 50 Hz harmonics frequency is 626 amperes. There the thermocouple A, the room temperature is 50 degrees centigrade. In the summer, we have tested in Dhanbad. So thermocouple B and thermocouple C has taken this result. One is 90 degrees centigrade and 92 degrees centigrade. Actually, there is a vital discussion is required. If the cable losses is not there, so temperature difference will not be there. Do you agree? If cable losses will be minimum, so at that time thermocouple B and thermocouple C temperature will be same.
Yes, sir.
Yes,
So
sir. Yes,
these
sir.
are the main feature. Here in this experimental system, that this path is fixed 2 meter away or 5 meter away from this cable. We have taken these two results. If the no loss in the cable, so at that time B and C temperature will be same. But it is certainly, we have got this difference of this result in the summer. There is a loss due to the injection of harmonics. These are the vital part. So here the higher order harmonics, these results are there. So we'll not waste our time. If you have interest, you will go through this result. I shall hand over this slide to your authority. So these are the discussion. It is also quite evident that if in power system network, where the significant amount of harmonic frequency is present, power system network LT cable should not be laying in touching formation. The temperature of thermocouple C is more due to skin effect and proximity effect of cable. So these are the points are there, and temperature difference observed is around 3%. And due to this temperature rise, the life of the cable will be shortened due to these harmonics. So these discussions are there. From the life estimation calculation of power cable, it is very clear that presence of higher order harmonics and cable operating temperature increment by an around 3 degrees centigrade, the effective life of power cable is reduced by 2928 days. It is not a matter of joke. So these results are taken from the manufacturer data sheet of the cable. That 3 degrees centigrade temperature rise, if it is there, so the lifetime of the cable will be shortened. Do you agree?
Yes, sir.
Therefore, it is recommended that all the equipment should maintain TSD generation limit as per IEEE or IEC recommendation or BIS recommendation. That means one standards are there. In IEEE also the standards are there. IEC also their recommendation. Even also India government, BIS, Bureau of Indian Standards, they are giving this for this type of cable, this ampere of cable, you can raise maximum of 1 degree or 1.5 degree centigrade rise. So maybe the power cable life will be more. So these are the discussion. The final temperature rise cable calculated through proposed method is very close to the temperature recorded through experiment. So these are the power plant economic analysis. These are the information for the different your solar PV installed in different countries, floating solar. So India and floating PV, first 10 kilowatt floating solar power plant in actually it is installed in Rajarhat in Kolkata. And this planning, NHPC is planning that 50 megawatt. We have also under my guidance that under the Maithan that hydel power plant, whatever the catchment areas are there, total catchment areas out of catchment area 10%. We have shown the calculation to the DVC that they are over this catchment area, they are generating only 63 megawatt, 20 megawatt each for two turbine. Another turbine will generate that's 23 megawatt with the electrical generator. So 63 megawatt. Apart from this, the floating solar PV, if it is over the hydropower catchment area, it will generate, we have seen that it is near about only 10 to that 12% area of catchment area, it will be covered up with floating solar. Then we have seen it is near about 363 megawatt, that 63 from hydro and 300, more than 300 megawatt generation is there from the floating. As because floating PV power plant will also always generate these advantages. So these are the advantages. They reduce the reservoir water evaporation. That is the main thing. In Jharkhand also, these are the vital point for Dimna Lake or that there. If it is there, so Jharkhand is a state where at the time of summer, whenever 48 to 50 degrees centigrade temperature is there, water evaporation rate will be maximum. So it will protect. So floating solar power generating system typically generate more electricity than ground mount or rooftop system due to cooling effect of the water, and more module installed compared with the other system. And here some views are there. The figure for offshore PV installation, river PV installation. In case of river PV installation, where the tides are coming, mooring system must be robust. Otherwise, it will be difficult. So these are the Sagardigi thermal power plant cooling water storage. From that, 5 megawatt FSPV will be generated. So it is also the Sagardigi thermal power plant. So here, these are the method how to float this, the floating solar PV system. So these are the views, different views. So these are the relevant publication for my scholars who have completed PhD. Actually, that fellow is the faculty in VIT Vellore, Chennai. Has completed this work, relevant publication, and the important I shall show you the work. If you click this over this animation commissioning of floating, just I operate this thing. If I operate, is it visible? Please respond.
Yes, sir. It is visible to us.
So this is the one multimedia views from YouTube videos. We have collected this thing for the installation of big floating solar PV power station. So these are the events, how to float this total system. That it is not possible over the boat you will do this thing. So have you followed this? So this thing is totally shown. So these are the system is required for anchoring. Here that NTPC, you will see that if you have interest, you will open this from the. Just I skip this ad.
In NTPC Ramagundam, sir, they are having 100 megawatt plant, 25 into 25 megawatt.
It is also, it has been started this.
In this video, we will discuss about solar photovoltaic power plant. As an overview,
And just you will see that
sun tracking systems
what are the, actually due to shortage of time, I have to cover up this other vehicles, contactless power transfer. So this type of information you will get from this link. So these are the operation.
weather data to be collected, you'd have a data logger that pulls data from those sensors and transmit them back into your SCADA system.
So let us, up to this, is it clear why this type of major power plants, floating solar power plants are required whenever the hundreds of e-vehicles over this grid? So grid turmoil will be there, and this type of the solar energy injections are required. Do you agree this point? Where the wind energy, suppose the winds
Yes, sir.
are available freely, there the wind power will be taken over this grid. Please respond.
Yes, sir. Yes, sir.
So huge amount of this power requirement. So efficient contactless this power transmission for up to this much. We are in Jharkhand, so for underground mining operation, there also the vehicles are there. So for this vehicle, earlier it is a contact powered vehicle. That means flexible cables are operating. I shall show you this. This is also that contactless power transmission. And why in underground mining operation, basically for coal mines, where the maximum gaseous mines, methane is deposited. So there the coal bed methane is a highly inflammable gases, and which will catch fire or mines blasting. So that's why there the switching of electrical vehicle or that contact flexible transmission is not possible. There, what is the system? That cable, just like your lift, you have seen one cable, power cable is in U shape. It is giving the power supply to the cage, another thing. So here it is a contactless power transmission. I shall show you that the arrangement. This is very simple. Yesterday, that before session we have discussed, this is very simple wireless electricity transmission, but it is very small for milliwatt or microwatt level. This is the transmission, that coil, and this is the your receiver coil. In between that, it will generate. So this is the need of contactless power transfer in mines. Increased mobility and flexibility in equipment. Basically, over this rail, the underground mines, from the underground mines, this the haulage route is there. This is called haulage. Basically, it is a like your toy goods train, that this coal will be filled up over this cage, and over the line it will be just taken this trolleys, and that will come out over the surface station. So here you see enhance the safety through cable related hazard elimination. So this is the underground views. So these underground views for these mines, the flexible over this cable, whenever the trolleys are moving, so the cable is over the surface of this. There is a friction, there is a cable surface damage. So there's insulation damage. Basically, insulation damage after 1 year, after 2 years, the long haulage cables are changed. So next thing, these are the condition for improvement maintenance or for the productivity. These are the lighting condition in the underground mines. We have collected these views from the dig body here nearby this place. Tata mines are there. So we have collected this. Now these are the coaxial winding transformer. This is CWT. Basically, I shall show you first, then contactless power transfer will. So this is the haulage vehicle. Is it visible there, this figure?
Yes, sir.
So this is like your railway line. This is the cross-sectional line. This trolley will move over the motorized action. But here, no use of the power cable for feeding the trolley. There, the contactless power transfer, it is a IPT, that inductive power transfer. The control actuators are there for power transfer, contactless pickup. One is transmitter coil, another is pickup coil. So secondary controllers. So these are the schemes. There you will see that three-phase supply will be just rectified. That means high frequency inverter and rectifier blocks are there. So this high frequency rectifier will inject the current over this primary. And this is the haulage system. Over this haulage system, this like the tachometer, that magnetic coupling is there, and it will move over the coil. So automatically it will transfer the power from primary to secondary. So this part is already, we have discussed in earlier session. We do not take this time. If you have interest today, you can ask this. So these are the basically air core transformer. It is in the stationary formation. That is the transmitter side. This is on the vehicle side. It will transfer the power. So this part is also we have discussed. It is not related with this part. They are only the first and second. So it is not 3x3 matrix. It is 2x2 matrix. There in this operation, mathematical matrix operation. Here, no need of n number of contactless power transfer. So this type of technologies are there, power transfer in mining application. So this is contactless resonating circuit again. There's the primary and secondary compensator is operating on parallel operation. Here it is series. So series parallel compensator is there. And specification already we have tied up this type of for transferring. Another method of transferring. That means here the coil is transferred. It is a closed contactless transfer. Axial movement is there of the coil. So there is no electrical connection. But this transfer is possible like e-vehicle earlier section. Already we have discussed this point that it is also possible in that case transmitter and receiver coil diameter will be a vital role, and maximum power can be transferred through the maximum number. In the lab we have seen that 45 centimeter of coil width, it will generate much more flux and uniform flux transfer, and which will couple the secondary. So efficiency for the coil width, in previous class also we have seen that coupling coefficient 0.8 up to this efficiency we have achieved, and 80% of efficiency for this system in the mining applications also we have seen. So thank you all. So this part already given to your authority. Is there any question? So please.
Participants, if you have any question, you can ask.
Sir, one question is
Yes.
there, sir. Sir, this is in case of the floating, cost of the
Floating. Okay.
the cost of the floating power, solar power, it requires a lot of base material. So so the cost may be high in comparison to
Actually, if you consider, I shall give you an answer that if you integrate the cost of land and the system, then it will be very less, as because that water bodies already stored. This land is unutilized, underutilized. So there, if you put this, suppose the in case of thermal power cooling water reservoir over this, we have calculated in the Bokreshwar. And in case of Maithon hydro power project, that there already catchment areas are there. Land is underutilized. So there, if you take this thing, then it will be very less. Otherwise, if you compare the land-based system and floating, only the cost is 1.2. That means 120% rise. As because this HDP floater, it is not indigenous make, it is imported now, till now. But later on, within 1 year, 2 year, it will come in the market.
Okay, sir. And so, what are the company, those who are manufacturing this kind of solar?
That is for the HDP, this platform, tilted angle platform, you have a requirement to search over the different sector. You will get this elements 14. They are in between this. 1 year back, I have searched this thing. So they are giving this, but it is totally imported, China make.
Because sir, in village area, it can be very beneficial.
Very beneficial. But again, also I shall show you that e-vehicle, whenever it will come, the total highway will be contactless power transfer system in Iceland, in Greenland, in Switzerland. Whenever this requirement is there, the utilization is underutilized, as because their wastage of power is there, as because they have no need of this power generation much more, as because their generation is greater than the utilization. So sometimes in the midnight, they are giving the power more or less cost of water. So there it is different in our country that indigenously, if you do this thing, so that will be benefited, that highways are passing through this, the water bodies, so you will get this benefit. Otherwise, that to protect the kettle or these things are there, whenever the e-vehicle dedicated lane will come. In previous session, whenever we have discussed this, it is very much dedicated lane there. It is a protection wall will be given for the protection of cattle, protection of cycle. This type of things are required. Whenever the dedicated lane is there, no one will enter. In metro railway in England, that not a single cattle or maybe the passenger or maybe the other man will be entered in their track. So that is required.
Thank you so much, sir. Is anyone want to ask question from sir?
Sir, which type of solar solar panel polycrystalline or monocrystalline panel used for mass power
Actually,
generation?
polycrystalline panels are nowadays we are using, but for solar, that upper glass, whatever the glasses are there, this glass special type of coatings are coming, like your this hardening of this glass, transparent glass, and one chemical engineering department from our department that they have filed this patent for the dust deposition. That this is basically all the solar panels are manually cleaned, and this robotic arm, whatever this thing, it is not possible in case of this solar photovoltaic panel. Whatever this for 5 megawatt, 50 megawatt, they are the manual cleaning. So manual cleaning, how can you minimize the manual cleaning? Maybe once in a month or 3 months, once in 3 months. But this glass is so slippery. I do not remember the name of the this material, that lacquering is required. So this dust will be automatically under slippery condition, it will be cleaned.
दीप्ति बाबा जितनी है टाइम मिलते सियान देख सैटरडे संडे 2 दिन की छुट्टी रहती है
2 दिन रहते हैं।
हां
मृणाल आप हैं?
Ma'am,
अच्छा ठीक है, तो हम लोग
dear
कंट्रोल
participant, any question, please? I think there is no question, sir.
Okay, thank you.
Thank you, sir.
Okay. Next time you plan over this.
For offline, sir, definitely.
Offline. Offline is like workshop. That
Yes, sir.
they can
Offline
do something.
with
That small,
hands-on training.
yes. Small experiment will be done. Whatever I have shown in the EDC, we have tested with the JRF, that fountain bed. Then we have tested this material over the swimming pool. This type of things are very much attractive, and
Yes.
this result will be accepted for validation also.
Yes, sir.
Thank you for
Thank you, sir.
inviting me for this.
Thank you. Thank you.
Thank you so much, sir.
Thank you, madam.
Yes, sir.
Okay.